Hi, today we're going to talk about terminating decimals, in particular how to change them into fractions. Okay, so the first thing you need to know is some prerequisite knowledge here. Place value. So you've all heard of place value before. It's a way to name digits in a larger number, or to tell what place they represent or what power of 10 they represent. So the first thing that we see here is to the left of the decimal place, we have the decimal here. It separates the way that we name the numbers. They're mirrored across the they're almost mirrored, so they're almost identical across the decimal place. So we start here with ones place, tens, hundreds, thousands, and so on. Notice that when we get to thousands, there are two others that are named with the word thousands in it, so it would be 10,000, 100,000s. Then we get to another unit called millions. Then we'd have 10 millions and 100 millions, then billions, and so on. Okay, so the mirroring happens when you go to the right of the decimal place. Everything's almost identical, right? We have tenths and we have tens. The only thing that you'll notice differently is that there's a TH here, right? Whereas over here, there's not a TH. So everything to the right of the decimal place has a TH. Everything to the left does not have a TH in them at the very end, that is. The other thing you're going to notice is that there's no such thing as a ones place. Okay, we do not have something that mirrors the ones place. That has everything to do with the power of 10 that we use to represent that. And we're going to go more into that when we get to scientific notation and we talk more about powers of 10. But for now, that's something that you need to know. So we start naming things with the tenths and then hundredths, then thousandths, and then we go into that process of naming it by 10,000th, 100,000th. Okay, so let's talk about terminating decimals into fractions. Terminating decimals, of course, has a decimal expansion where there's only value in a certain number of digits. Here we have value in 3 digits here. Now remember that I can keep adding zeros here, right? So we don't call it terminating because this is a terminating decimal, and we call it that because the value stops at a certain point. So in the decimal expansion, the value stops. All right, even though I can add zeros into it, it's not classified as a repeating decimal, even though the zeros repeat, because the thing that would have to repeat is something that actually had value, and zeros don't have value. So, or it doesn't add value into the number when it's placed to the right of the valued numbers on the right of the decimal. Okay, so turning this into a fraction requires you to name the number. So let's go and name our place value. We have tenths, hundredths, and then thousandths. So what I'm going to do is I'm going to use 1,000 as the denominator here, and I'm going to put this number into the numerator. Now they both share a common factor of 2, so I'm going to go ahead and continue to reduce these. Okay, that's 64 over 250, which is the same thing as 32 over 125. Now I know this is reduced because 125 is a perfect cube. So this is 5 cubed, meaning it only has 5 in its prime factorization. Now 32 is not, 5 is not a factor of 32. Therefore, the only factors of 125 are not common with 32, so it's already reduced. Right? So I've changed this terminating decimal into a fraction. Let's look at one with a value in the ones place here. So this is going to be first converted into a mixed number. Now remember, I can write this quickly as 6 plus 0.1807. Now just a word about the convention of putting a 0 in the decimal place. Or in the one spot here. Some people don't like to do that. I always like to do that because I worry sometimes that people won't see my little point here, especially if I make it small, and I wouldn't want them to confuse this number with this number. Okay, so if you miss the decimal point with your eye, you're going to confuse this small number with this very large number, comparatively large number. So I always like putting a 0 here. It's up to you, but if you don't put a 0, make sure to put your decimal place pretty big. Okay, all right, so this number is 6 plus 0.1087. All right, and so what I need to do I'll put 6 over 1 so that I can eventually add together. Now, again, I want to name this number by counting the place values. So we have tenths, hundreds, thousands, and then 10,000. So again, 10,000 is going to be in my denominator, and I'll have 1,807 in my numerator. Now to add these together, I'm going to have to multiply this by 10,000 to get 60,000 on top, 10,000 on bottom, plus 1,807 over 10,000 is going to be 61,807 over 10,000. Now, there's not really a quick way to, these are commas, right? These are to indicate that I have a lot of place value here. Now, there's no real quick way to determine whether or not 61,807 has a factor that is also common with 10,000. I'm going to show you a neat trick with the calculator here. So I have this calculator, and I'm going to put in 61,807 here. Oops. Let me clear this out to show you how I did this. I used this stacked fraction key. And, I mean, this trick only works if you have a calculator, right? So if you don't, you're going to have to be stuck using some rules to figure out whether there's any factors of 61,807. Okay, use this little arrow. Whoops. Let me go back. It should be on the outside. I should have arrowed to the right here to get to the right of the decimal place. So I'm going to use this little key here. It says that you want to go ahead and try to simplify this fraction. And if you press enter here, what you're going to get here is, it says domain error. Now, unfortunately, it's not really descriptive. But what I know when I get this, when I'm trying to simplify, is that the number's already been, it's already in its simplest form. Otherwise, if I gave it something that was supposed to be simplified or could be simplified, it would show me the simplified version, and it would tell me the factor that I could reduce it by. So for instance, I put the fraction 25 over 125 in. I asked the calculator to simplify it. It tells me that the factor is 5, that reduced it by 5. It tells me that 5 over 25 is simplified, but it also gives me this right arrow, meaning that it can be further simplified. So if I go simp, and it puts in my last answer, it tells me to simplify it, and again it reduces to 1 over 5, so the factor is 5. If I asked it to simplify again, it would just give me the same fraction. Weirdly enough, it doesn't give me the domain error that, that I had as last time, but this is one way to simplify something that's already that can be simplified. Otherwise, you have to just look at the error message and understand that that's what that means. All right, that's the end of the lesson for today.